Hello, everyone. Oh, I gotta mess with my. I really need to do something about this. I don't like the C920. I don't like it. There we go. It's a little better. Hello, everyone. Happy Valentine's Day. Hey, Bartleby. Yeah, I've been slowly recovering. I'm mostly better now. I don't feel sick, but I am definitely low energy. So sorry if that comes across tonight. Yeah, usually I try to be more energetic, but it's late. Hey, Merlin Shaw. It's late-ish for me, and I'm tired, and I'm recovering. So, yeah. But I have a challenging thing for me, a challenging stream for me. This is going to be a sponsored stream, PCBWay sponsorship stream, but we'll get into that in a couple of minutes. The challenging part is going to be, I have never soldered hand soldered. I say hand soldered, I'm not actually going to be hand soldering, and I guess I'm going to use my hot air rework station, but an RP2040 processor. And I guess we could talk about what I'm going to be doing. You might know already if, let me just get some stuff here. You might know if you've been watching the last few streams. Oh, excuse me. So maybe a month ago, maybe 2 months ago now, we worked on this. This is called, oh gosh, well, you know what I'm gonna have to do? I'm gonna have to make it look terrible. Do one of these, yeah. So I'm gonna be blown out, but you'll be able to see this better, hopefully a little bit better. So this is PicoGUS. It is a Gravis ultrasound emulated sound card for vintage computers, DOS computers mostly. But this is this specifically is the 1.1.1 version. So this is an open source project, but this is a DIY friendly version of this project. It was kind of meant to. It's still challenging. It's still surface mount. Some of it's still surface mount soldering, but the most difficult part, which if you looked at every single piece individually across all the parts on here, the most difficult part to solder or to do it yourself solder would be the RP2040 processor here on the Raspberry Pi Pico. So the Raspberry Pi Pico is a dev board that it kind of gives you the advantage if you're a hobbyist or if you're working on any sort of project that you might want to use a Raspberry Pi Pico for. It gives you access to a Raspberry Pi or RP2040, which is the microcontroller, but without needing to solder it yourself. You can kind of just wire up the Pico board, and yeah, it kind of handles the difficult part for you, which would be to wire up a RP2040. But yeah, don't get me wrong. I mean, this is could still be challenging for somebody who is not super used to surface mount soldering, because there's still a bunch of surface mount chips here. However, it's not the most challenging form of this project, I guess we should say. So the oh, and I have my PCBWay cup. Shout out to PCBWay. We'll talk about them in a second. So this is the 2.0 version of the Raspberry Pi. No, the 2.0 version of the PicoGUS. Now, I think the main difference, feature-wise, from the 1.0 version and the 2.0 version, I think the only thing that's different is there's a wavetable header. So if you had a wavetable add-on card, you can connect that to this. Now, this doesn't have, the 2.0 version also has a USB-A port in the back, which enables you to use, it acts like a game port for controllers, so you can connect USB controllers. However, it gives you a full-size USB port, whereas I think you can also do that with the 1.1 version, but you would have to use a micro USB to USB Type A adapter, and then also you're on your own kind of how to get it out of the case. But it does work. It would work, I think. So yeah, so that's the main difference, like I said. So you get a full-size USB port in the back, which so I'm thinking like maybe an Xbox 360 wired controller, or there's a bazillion USB controllers nowadays, and it kind of exposes it in the back of the computer when you use this, and the wavetable header. I think that's really the two different things. The 2.0 version of this card, if you look at the GitHub repository, it's in a section of the repository called Chip Down, which I've later found out is sort of like kind of like slang for a version that is meant to be produced like by a PCB manufacturer like PCBWay, that they would hey Ian, thanks. Ian Scott here is the developer of the PicoGUS, so shout out to him. So yeah, the chip down version is a version that is meant to be built by a PCB manufacturer and not necessarily DIY. But I'm kind of, I'm always looking for challenging soldering, and for the most part, the thing that I'm concerned with now is the actual Raspberry Pi RP2040 QFN part. I'll show you in more detail about what that means, or I'll give a visual, I suppose, of what that looks like in a couple minutes. No worries. It might be some stuff just want to talk about some stuff before I just dive right into it. But yeah. So I guess before we do that, before we talk about the actual challenge, I'll just give another quick shout out to PCBWay. They've been a sponsor of my channel for over a year now. Most of the actually, yeah, well, okay, not all. Most of the boards that you've seen me ever work on, populate, I suppose, have come from PCBWay. So I really dig the quality. I really have never come across a board yet from them that has not worked, which is, that's kind of surprising. Like I kind of would expect, maybe at least one of them would just straight up not work. But so far, I've had really good luck. So yeah. So other things PCBWay can do, I guess, other than actually make custom PCBs for you. If you want to make an open source project for yourself, you can upload the files, the Gerber files, to them, and they'll actually produce the PCB. But they can also do that chip down process like I was talking about. They can, if you supply them with a list of the materials, the bill of materials to go along with the board, as well as some other files that they need to know how to place the parts, they might be able to just straight up produce this whole board for you without you having to solder it yourself. Other things that they've done that they're capable of doing that I've had done, that sounded weird. Other things that PCBWay can do, they can do 3D printing. If you don't have your own 3D printer, they actually made the resin shell for my Ashita handheld Wii. There's some videos about that if you're interested in that. But they can also do injection molding services, and that's kind of a super lengthy process involving creating mold and all that stuff. But they have those capabilities, and they also have CNC machining services as well, so they can machine metal and stuff. So that's pretty much the spiel for PCBWay. But again, thanks to them. Really, I'm really glad that they are still sponsoring me and give me the opportunity to build, I don't know, challenging open source projects. All right, so that's that. So, yes, water. All right, so let's talk about QFN, I guess, and what the challenge is with QFN, and specifically the challenge with the RP2040. So let's head over to the bench. I've got both the, this looks a little dark now. Oh boy. It's always something not working with the stream setup. Hold on, it's not working properly. Let me do one of these. Does that work? Hello? Oh, come on. I think it's this one. Okay, this. Let's unplug that. Plug it back in. Then I might have to fiddle. There we go. Hey, we're back. Okay. All right, so I've got both the camera and the microscope set up. I guess I should have shown you on the microscope. It might be a little easier. Yeah, definitely a little easier. Let's go to the microscope. Which, to do that, I need to turn the light off so this glare goes away. Okay. Hopefully we're still here. Yep. Okay, cool. Oh, you know what? I didn't open my comments too. I'm gonna bust up in some comments while you guys stare at this nice red board. Hopefully everyone's having a okay day, whether you celebrate, do anything for Valentine's Day or not. Okay, almost ready. Okay, that. Okay, cool. We have comments. Nice. Okay. All right, so for the most part, let's actually bring over the other PicoGUS. So for the 1.0 PicoGUS, there are a lot of these type of surface mount chips, I suppose. I don't remember the names of all the chips off the top of my head. I'm not a professional. I just kind of pretend to be one on YouTube. But there are these types of chips here where you can actually see I guess they're called leads, right? So those would be the metal parts that you actually solder to on these chips. So in this particular case, you can see the leads here, which means that, if you can see them, you can, solder to them here and make a good solder connection with these exposed pads on the board. So there's a bunch of those actually on the PicoGUS 2 still. So I'm not going to be able to populate this entire board tonight, but I'm going to see how far I can get. So here would be what those types of exposed lead, I guess, pads would look like. Right, so you can actually solder to them individually if you wanted to. Now the difference between that and QFN, which is what a RP2040 processor looks like. Let's actually get it out of the bag. Now I'm hoping that this is a real. Hey Leon, Voltage translators. I was just thinking, what's the name of the footprint? Not the what are these footprints called? That's what I was trying to think of, not the actual part. I know even less about how stuff actually works versus how to solder it. Let me get my tweezers somewhere. Tweezers? There they are. Excuse me. Sorry. Hopefully that's not destroying your ears. So I hope this is a legit part. Okay. So here's what the actual piece looks like. Right? And so you can note, oh, TSOP. Okay. Got it. TSOP. What does that stand for? Just curious. Thin, shrink, small outline package. Wow. Okay. Yeah. Okay. So this is the RP2040 processor on the right, and you can kind of notice that there really isn't. Well, there are. Well, actually, they're really not exposed at all. There really aren't any exposed leads. I mean, they're there. They're there, I suppose. So that's one of the advantages of having a microscope, is being able to see them like this. But you notice that, like, even this one here at the far end is not attached to the pad on the bottom. I actually watched a good tutorial, and I'll shout out to this person in a minute because I wanted to go back over to the desk in a minute to talk about something else, something related to this. So I'll shout out that video. But they mentioned the same thing, where sometimes the parts that come out of the chip don't necessarily correspond with a pad, or even if they do correspond with a pad, they may not even be attached still. They're really just for a reference, like a positional reference, to see where they are compared to the pads. So I thought that was kind of interesting. Now, so that's kind of, so let's say if I line this up, and I also kind of learned that for this board, here, this the indicator for pin 1, which normally on ICs is like, in this case, it's this round, this circle here would indicate like pin 1 would be either that pin or this pin here, but that is like the orientation of the chip. On this solder mask here, the silkscreen printing, this the corner that only has one line is the one corner, versus all the other ones have kind of corners. Those are not. So basically, the orientation of this chip eventually will be like that. But yeah, because it's not, the leads are not exposed, really, I mean, this is not how a production company would not do this at all. I mean, the real method would be, anytime you design these boards, you would also get a stencil, which would be like a cutout of where all the pads are in the entire board, and they would squeegee solder paste on there, and then they'd put this, then they'd use a pick and place machine and put all the parts on the solder paste, and then they'd run it through a reflow oven, and they would melt it in an oven. So it would, I mean, I suppose it's like hot air, but it's not really like hot air. Not the same way that I'm going to be using hot air. So I'm going to head over to the bench, and we're going to talk about something that person that I watched mentioned. I don't necessarily know if it's going to help me, but I mean, it's interesting information either way. And I thought it was interesting, so I'm going to share it with you. So let's go over to, so this is the Sean Hamel, I guess, but it's like this DigiKey YouTube channel. So this is a cool guide. If you're, I'm going to be replicating this method in this video. So you don't necessarily have to watch this video, but I just wanted to shout out that I got this method from this video here. Yeah. Okay. So in the video, they talk about the actual process, like I was telling you about, when a company would build a whole bunch of these boards, they would either pick a place machine and then they put them through an oven to melt the solder and then, cool it afterward. But you might be curious, how did the board manufacturer know exactly how long to heat it and at what temperature? And every part basically on a board, usually they have a data sheet. In the case of an RP2040, it definitely has a data sheet because Raspberry Pi Foundation, they have really good documentation. And I was surprised to see that they actually do have a solder profile. So a solder profile is basically part of the data sheet that tells you what temperature and for how long to heat a part to have it be well soldered, I suppose. So, and also right off the bat, it says it's a lead-free part, which I guess means internally it's lead-free, but also maybe that it was meant to only be used with lead-free solder, which is, I'm not sure if I'm going to be doing lead-free solder or not. I guess I'll ask again before we dive in whether you think I should do lead-free or leaded solder. Normally, 99% of the soldering that I do is lead-free. Or no, leaded, sorry, not lead-free. So I'm more familiar with leaded solder. But, this is a lead-free part for whatever that is worth. But the kind of interesting thing in this case is this temperature profile. So this is, if you I know there's actually a bunch of like do-it-yourself reflow oven kind of projects where you could use like a what is it called? Toaster oven, and you kind of like hijack the toaster oven, and sometimes they have like PID controllers and stuff where it actually like can maintain a proper temperature and introduce these profiles into it. So maybe some year I would be interested in building my own reflow oven, but that's not today. But the interesting thing here is this profile. It kind of gives you go with leaded. Okay, all GPU, iPhone, and laptop repair guys use leaded, and I can imagine they use leaded instead of lead-free because the leaded solder has a lower melting point. And actually, I was watching Northridge fix. Northridge Fix was fixing some 4090s or like graphics cards or something. And first, it was like the power connectors he was replacing. And first, he would use low melt solder to just get the thing out, get the plug out, I suppose. So low melt is even lower than leaded. It's like purposefully really low temperature so that it stays liquid longer, so that you can liquefy all the pins and then pull the connector out. So not necessarily related to this, but I thought it was kind of interesting. Anyway, so I'll probably end up using leaded solder just because the temperature is lower. So the success of a good joint is probably higher, a little bit higher maybe, in my case anyways. Okay, so the temperature, long story short, and I kind of got some of this information from that other video, there's kind of two parts of the process, right? So the first part is going from basically cold to this preheat time. And after the preheat time is sort of like the final soldering time. And both of those areas, both of those time periods, right? So the preheat time and then they call it T here, but it's really like the time where the solder is liquid and making a connection with the part. They're defined in a table here. So the first thing that we need to know, I suppose, is, how long do we have to preheat it for, and what's the minimum and maximum temperature we need to stay in this preheat time. And it's all in this table. So it says time T of S, which is, it corresponds with, sorry, I don't know why my computer's lagging on this PDF. T of S here is the preheat time. I know it's kind of confusing, but yeah. So it says anywhere between 60 and 120 seconds, which is from 1 to 2 minutes. So we have to, and what's the temperature associated with that? And that is it says T min and TS min and TS max, which is the preheat temperature. So that would be, this preheat area would be between 150 C and 200 C. So basically we have to maintain between 150 C and 200 C. Technically it's supposed to be like at the part itself, I suppose, or like where the joint is. But yeah, around it, ambient, I guess, around it. Between 150 and 200 degrees for 1 to 2 minutes. That's the preheat. Now, I don't even think that the solder will be liquid at that point. That's really just to get the board and the part itself, I suppose, up to a temperature where it can more quickly move into the liquid, or like the wet stage of the soldering. So that's the second T, I guess. It's T nothing, T whatever. So this second time period here, at the top of this kind of scary looking, I don't know, parabola or whatever. This T of P, I think, is like the scary area of don't go here, maybe. Actually, what does it say? So T of L, I believe, is the time here between the actual liquid temperature, or liquid time, yeah, the time period that the solder should be liquid is this here. And that is between another either 1 minute to 150 seconds, which is 2.5 minutes. So anywhere between a minute and 2.5 minutes is where you want, where the time period that you have for the solder to be liquid and for you to position the part correctly. And there's other stuff like, I think that's this T of P or TP, whatever, is within 5 degrees. Like, I think, I believe it can't be hotter than a certain temperature, which is what, 260. I don't think it can get hotter than 260 for more than 30 seconds. Here, that's this, I think, TFP, right? Yes, within 5 degrees of the specified classification temperature. So I don't know if this means it's required to be within 260 degrees for 5 seconds or whatever, or for 30 seconds, or if that's like, it can't be higher than that for 30 seconds. Because I think you kind of just want to nail this temperature here. I hope this isn't boring. I hope this is useful, interesting information. But all this information together, it creates a solder profile, which is the correct temperature and amount of time to solder the RP2040 processor to that board. So you might be asking, how am I going to be able to accurately maintain any of these temperatures? And really, I'm not. But we have something that we can try. Again, according to that video. So let me, I'll go over to the microscope. Or actually, we'll go over to the bench. I have my multimeter, and it has a thermal probe, or just a thermocouple. So it's this little thing, this little temperature probe thing. You know, it's kind of a ball thing. And this, so I have a both Fahrenheit, and I'm going to use Celsius. And as you can see, when I hold it, you know, eventually that temperature is going to rise. Actually, I don't know what 22C is. Is that hot? Oh, it's going up. So I'm holding it in my hands. It should, you know, it'll go up. Or if I put it in my mouth, it's kind of gross, but that's taking the temperature of my mouth. So they kind of suggested, or they, at least in their video, the DigiKey person, they taped this bad boy to the board. Now, I don't know, that's definitely not a super accurate measurement. And especially, I think it's literally the measurement, it's supposed to be the measurement of the solder. Or like, you know, this is not going to be a very accurate way of measuring the temperature. But at least in their perspective, it gives you some indication of the ambient temperature around this thing. So that might give you, like, you know, obviously if it's way hot or way too high, that's going to give you some good information. So it might not be able to it might not be the most accurate thing for this, but I'm curious. I'm interested to know. You know, I know about how long I normally solder things with my hot air hot air station, but is this gonna help or not? So I'm gonna put it close-ish to the pads, right? So it's not exactly on it. It's kind of, you know, there-ish, and then oh no, is this? Oh, okay, maybe the batteries are low. And I'm not really gonna like put it in the stream, although I guess I could. Do you guys want me to put it in the stream, the temperature? I think I have a way of. Can we? It doesn't really help me to see it, but I could do one of these, which is basically switch to my microscope, and then let's get the board in position. Oh, girlfriend's home. Open the box. Okay. And then I could add. I'm over at my desk. I'm just gonna add video capture and the cam link. Oh, and it's upside down. Oh gosh, undo. Wrong thing. Hi. All right, so if I rotate this, and then I can make it smaller. Oh gosh, wrong thing. This. Right? And then I don't know. This is just kind of an experiment. But that'll give you the temperature of that probe. Hold on a second, guys. Okay, I'm back. Okay, that's a cool tip, Bartleby. Excuse me. So Bartleby was saying, so we'll get into, I guess we'll get into the method, which is going to be, so I've got my hot air rework station. I'm going to set it to the same temperature that person used. They set it to 300. And I'm going to put it in like 50C. That's what they used. So I've got 300, 300C temperature and 50% air. And I need my iron. I guess we're going to try to, I don't know how exactly, oh, I guess I can use my microscope, duh. So I guess Bartleby was saying to kind of pre-tin these leads. Just waiting for my iron to heat up. My only problem is just to make sure there's no oxidation on them, which okay, I suppose. I don't know if this is, let's clean this tip better. Okay. Oops, shoot. Oops, ah. Oh no. I don't like this. Okay. I'm trying to look through my microscope and it's still got some sea legs there. I don't know. I think I might have melted a little bit of the chip there. Well, let's keep going anyways. Gone this far. Okay. Last side, I guess. Okay, cool. Well. Huh? Are those pads even there anymore? Did I just rip them off? Maybe that was a bad idea. Well, I hope I didn't rip those pads off. No, they're there still. I think this just the actual package plant is like plastic that I'm ripping off. Oh, I got a hair on my thing. Get off there. I don't know if this is helping at all, but science. Okay, cool. No, I don't think I did. Leon, Bartleby was saying to make sure there's no oxidation on the chip by pre-tinning it. So that's what I tried. Okay, so that's fine. It was there. It's just I think what's happening is the plastic, whatever the chip, the actual IC is made out of, is kind of plasticky and getting melted a little bit. I think the actual lead is there. It's fine. Yeah. All right. Cool. So yeah, now we can actually pre-tin the pads here. I'm just gonna put some Amtech flux. I probably could tin it first. I don't really need to put this on yet, but yeah, I don't know. This is VS213 Amtech flux. Actually, you know what? The guys, I don't know if it really matters one way or the other, but they tinned the center pad first. Don't really know if it matters that much. Okay, so that's the center. Now let's just kind of, I don't know, drag solder the rest of these pins here. Just trying to get it kind of evenly coated. I think a bad thing would be to kind of have, if you have too much or too little, you can't really fix it. I think this looks fine. You know, I mean, you still have gravity. Gravity is going to push some of the solder out. So it's not like you're totally... There's a little wiggle room, probably. Plus, I mean, these are designed for solder paste. So, you know, solder paste is probably not super duper accurate either. Okay, so with that, I guess we can just start. I guess. I'm going to kind of zoom it out a little bit. And remember I said that this is the one, or the pin 1 indicator thing is the not triangle spot here, or the corner. So like this is a corner, this under here is a corner, that's a corner, that's not a corner. So that's 1. We're going to just do that. Okay, is this thing still, okay, this is still working fine. I guess I'm gonna try, so the game plan is what? Anywhere between 1 minute and 2 minutes preheating, which would be, you know, kind of maintain the thermometer at 150 C, or between 150 and 200 C for 1 to 2 minutes. And then I'm just reading this off and this is for leaded solder or lead-free solder. It says that the liquidus temperature is 217 degrees C. So it probably is going to be lower for leaded solder. And that's between 1 to 2.5 minutes. Okay. So I'm just going to give it a whirl, I guess. My general strategy, I suppose, for hot air stations is kind of like the circle thing. Huh? Something's yelling at me. Okay, I hope my... All right, so I'm looking at that thing. I'm kind of trying to get the board to that 150 by just raising the hot air gun up and down. Trying not to, looks like it's gonna blow it away. Yep. Okay, so this is fine. Might have to turn the iron down a little bit. Have to make sure to maintain the orientation. I'm gonna add some more flux actually before I go back. There's going to be 1,000 people cringing at the screen. You know what? Fine. Cringe. This is how I'm going to try to do it. And if you don't agree, then do it yourself. That's what I got to say to the haters. Okay. That was just the iron turning off. Oh. I guess my thing here obviously does not want to stay on forever. Okay, so let's try that again. I'm turning this air down, I don't know what, 25? 20? That seems like not much, but we have the temperature statistics that we need, so hopefully it's still lined up. Just kind of doing my circle thing. We're not at 150. Getting close. Again, that's ambient temperature too. I'm going to turn it up the 25%. Okay, so we're getting to that temperature. All right, so now we just got to wait a minute. Anywhere between 150 to 200. Not super keeping track of the time, but I should. I'm just keeping an eye on the clock. I'm gonna have to turn the temperature up, I think, or because I don't really want to risk the speed, but I need to get over 200 or whatever. Okay, so I think we're over our preheat time. Just adding more crap ton of flux. So I am gonna turn up the air, I suppose. I gotta get over that 215 or 17 degrees.
Can I see calibrator, please?
It's in that bottom drawer there. I can't. I'm doing something that's timed. It should be in the bottom there. Oh no, it's on my table there, under that stuff there. Okay, sorry. All right, so we're gonna get up to that temperature, 200 degrees. Yeah, I do want to get a hot plate. Okay, we're over that 200 degrees. Don't want to go over 260. I'm just going to keep an eye for another minute or so. It's kind of hard. I can't even see. I guess I should be looking at this. It's hard to look at 1,000 things at once, guys. Sorry. It's kind of working, I guess. Okay, I think we're fine. I'm just gonna let it cool down. I'm gonna try to like look at the side of it once it's cooled down. Normally when I do normally when you use the hot air rework station, you can kind of feel the like surface tension on the board, like on the piece. You can tell when it's where it wants to be, and this is kind of difficult. It didn't really, like, it was just stuck, which is, you know, could be fine because there is a giant ground pad in the center. But it was difficult. I don't know. I don't even really know if we're lined up that well. We could try to look at an edge. Suppose. Not really working well. All right, I'm getting this thing off here. Thermocouple. Okay. I guess. Let me turn the light up. Well, kind of just unsure. Can't really see well with the glare. Some sides look lined up. I mean, this side looks fine. Well, it doesn't really look like there's good connection. I suppose. Well, you know what? I think I might have to ditch my idea of looking at the temperature and try to do it more on like surface tension, because I'm not really satisfied with that. Where's our part? There we go. I don't really know. Yeah, a mini hot plate would be really good. That's definitely something I want to get, and they shouldn't be that expensive. All right, let's try it again with hot air. I'm going to try to use the tweezers to kind of poke it and see if we're getting surface tension. You know what I mean? It was kind of too hard to focus on the temperature and make sure I wasn't getting like blowing the flux away or like blowing the piece away. I'm gonna also try to look at the actual scope, like output, and see if I can see melting solder. Okay, so now it's a liquid. I think I actually made it worse just now. Okay, well, I think that's fine. I mean, it's back in that same spot, so it's kind of what I was hoping for. Now, I guess what I probably should do no, it wasn't blowing the piece away, Mo. I've been adjusting the airflow. I'm just trying to. It's really difficult with this this piece. Normally, when I'm doing hot air stuff, I can kind of feel the tension. Like if I'm doing a part, like one of these parts here, I can sort of feel like when the solder is melted, and it just kind of self. It's hard to explain, but self aligns. This is a little more difficult because there's a huge ground pad on the bottom, and two, these are a lot finer pin pitch, and they're kind of all over the place. They're like on every side of it. So I think that what we could do, maybe figure out what pieces that we need to, other pieces that we need to solder to flash firmware onto it. I think there's a little, maybe there's a guide somewhere. Maybe Ian knows, or it's on the website. I have a much bigger one. I have a much bigger size nozzle thing, like this compared to this. But I like the small one. Yeah. Well, let's look at the documentation, and maybe there's some helpful insight. Because I think at this point, I mean, we don't need to populate every single thing to get the firmware flashed, right? So I think the firmware gets flashed through the USB port here. So if we can get to that, if we can solder all the pieces that it needs to flash the firmware, then we can actually confirm whether or not this thing is even soldered correctly. So let me get a napkin because I'm all fluxy. It looks fine. It looks straight from here. Anyways. Oh, that's funny. All right. I thought I saw somewhere. Let's see. I don't know. Probably not. Ian, do you don't happen to know what I might need for that, right? Do you? Obviously, we need the port. Oh, I broke it. That's weird. All right. I know there's the build guide here, but there's no build guide for the 2.0 version. Okay, so we need a button also, I believe, right? I'm assuming it's probably all this stuff here, a couple things here. Oh, actually, you know what? Is this is the programming port here. So probably this programming port stuff, and then like probably a couple of SMD components around here. Ding, 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 ding. Well, okay, I guess I should, well, I hate to start soldering surface mount stuff. Let's clean this off and have a look at it. I hate to start soldering surface stuff around the Raspberry Pi with the RP2040, but You need all the decoupling capacitors around the RP2040, XTAL, the caps on the XTAL, the resistor. What does XTAL stand for? All right, let's clean this off. Maybe at this point all the haters tuned out. Just kidding. You know, I don't view other people's opinions as hate. So, you know, unless you're really bashing me, then I think most people have, you know, they're on my side. Let's zoom out a bit. Oh, I guess we already were. Got a lot of reflections from this light. Okay. All right, so, wow, you can actually see where these things, what I need, kind of. So I hate to solder these components, but, you know, if it's necessary, then just trying to see if this side here looks like it lines up. Yeah, I mean the pins seem like, just trying to look at the edge pins, and they line up there. This is not a good idea. This is not, yeah, same here. Yeah, okay. Hate builds character. Yeah. All right, so I guess we'll start from here. All right, what is XTAL? You need the decoupling capacitors, XTAL, the caps on the XTAL, the resistor in line to the XTAL, the micro USB port, resistors in line on the USB traces, and the button. Oh no, I'm losing flux. Okay, I'm just thinking. I guess I'm just going to start soldering all the surface mount parts around the thing. Okay, so I guess the other thing, I didn't really mention this in the beginning, but the other thing that might be difficult for some people is these components, basically what I'm about to do now. Which is these, I think they're 0204 sized components. So now I need to find the bags, but it makes it way easier when you have the when you have a microscope. It makes it human instead of like you need to be super good. I'm just gonna Google XTAL. Oh, the crystal, the clock crystal. Got it. Okay, so there's a crystal nearby. What is the reference designator? I'm just looking it up on the 2.0 bill of materials. Going to So here's the chip down part I was talking about earlier. Parts. Is it a different spot? I sort of remember having a hard time. Oh, here's the bomb. Okay. Okay. Crystal. Aha. Okay, so Y1. Where's Y1 in relation to this stuff? Oh, right here, right? Y1. So I need that. All right, so I think in general I need to start solder like a lot of the stuff around here. So that's what I'm going to do. I'm going to start soldering and sort of work my way toward the USB port, which is down here. The programming port, not the type A. Okay, so let's get some stuff out of the bag. I'm going to look for capacitors first. Nope. Got a big old bag of stuff. This is always the worst part for me anyways, is trying to keep things organized and not a terrible mess. Oh, please tell me that there are reference designators on here. Well, oh gosh, nope. There are not a single reference designator on any of these. Oh man, LCSC kind of, oh, there are some. Okay, never mind, I'm wrong. They were just in the wrong spot. I ordered all these things from LCSC. So this is different. Normally I order stuff from DigiKey, but some parts were not available on DigiKey, so I ordered just everything from LCSC. So this is R10, R11, R13. Is any of that stuff close? Nope. I don't see. I see R16, R15, R14. Okay, R17. Nope. So I'm looking for what, like C30, C35, which should be a big old pile of them. Oh, wait, R15 and R16? Do I need that? That was, yeah, that's one of these. That's those guys here. Okay. Well, I have those, so let's start there. Oh, gosh. These guys are small. Hello. I don't know why I ordered 100. Oh, the quantities for on LCSC are kind of bonkers. I think it was like decently affordable just to order 100 of these, even if I needed like 2. So, yeah. Okay. So I've got some resistors out. This is for R15, R16. And I'm going to keep a pile of like, I've already done those over here somewhere. Okay. All right, so let's start with 15, I guess. And R16, I guess I might as well just do them both. Where are my little tweezer guys? Tweezers. Oh, they're under the bag of stuff. Obviously. Okay. Trying to look through. I'm still trying to get oriented by looking through the binocular things. Can always fix it later. Okay. Now, see, this is where it gets dangerous if I had to reflow the RP2040 when I start soldering stuff, like adding other components. Whoa, that one wasn't ready. Come on, guy. There we go. Ding, 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 ding. Doesn't this look fun, guys? Don't you want to challenge yourself to these crazy soldering projects? Okay. Okay, those look good. I mean, not great, but fine. Is this the scope I bought? Yep. Not zoomed in all the way even to, I could go, ugh. It's not autofocus either, but. Yeah, I could go in a little more. All right, so that was R15 and R16. Let's see what else I can find. C1, C11, C38, are any of those nearby? See, now I can't really see the reference designators. Nope, I don't see any of those. Okay, well, moving on. I like it a lot, Mo. I didn't, you know, people have been telling me for a while to get a scope, and it's not like I didn't believe people, but I didn't know how much I needed a scope, I guess, and how much it really does help. It makes things that before I would have been like, ugh, this is annoying, and like a strain on my eyes or something, like these footprints, these 0402 or 0204, were, you know, doable by eye, but definitely hard. Now there's probably like 20 of those on this board, so multiply, you know, how difficult it would be to do one and then have to do 20 and just kind of forget it. So basically it would enable somebody who wouldn't normally do this particular, you know, project. They might be like, oh, okay, well, maybe I can do this, right? So, yeah. Okay, I'm looking for the bag of capacitors that has there's like a ton of them on the reference designator for the customer, whatever. I need a box to put these things in. Ah! Don't drop anything on the floor. C24, C25? No. All right, this one starts with C14, C15. I gotta find that one. Just kind of off. Oh, here it is. Here's the big bag of a bunch. Okay. So let's see. Now I have to cross-reference everything. Okay, Okay, so if we start like up here-ish, C24, is that one of these? No, it's not. Okay, fine. Is C35 one of these? Yes. All right, so let's do C35. Yeah, it does, for sure. You know, I don't know why. I kind of like, you know, you could just buy this 2.0 version of this card. So like if you really don't want to hand solder it, you can just buy them. But they, you know, you have to wait for Ian to have stock of them. But it's just kind of interesting to me that I can just make it, you know. Yeah. Doot. Okay. All right, there's got to be more in this area. Is C32 one? Yep, C32 is one. Okay. See, now I found all the, this must be all the filter caps. Now, unfortunately, I'm probably not going to be able to finish all of this, but this is what I'm going to be doing to test. Well, obviously, eventually, I'm going to be populating the whole thing because I want one of these 2.0 boards. You know, first stage is to make sure that I've soldered the RP2040 correctly. New little flux. Okay. So that was C32. Is C5 one? No, C5 is different. Okay. All right, so let's go. Let's keep going around. Are these? So this is what? C26, C29, C37. So let's start with C26. Yep, C26 is also one of these. What was the other one? C29, C37? Nope, C29 is not. Oh, I see C3. Oh, C4 was one. Oh man, or no, C5? C5, okay. The bomb is weird. It goes like C14, C15, C16, and then C2. So it's kind of like alphabetical by number instead of by numeric value. So shoot. Let's go back. This C5 was also a cap. Bypass cap, I think one of these filter caps, I mean. C5. Okay. I need some better tweezers for this small stuff. I don't really know what to get though. Oh, see you later. That piece just went flying and now I don't know where it went. This is why it's always a good idea to buy a bazillion of these small 0402 or 0204 or whatever size ones, because they can go projectile and then you're never going to find them again. Okay. Okay, so C26, 29, I think all three of those on this side are. C26, yep. C29, no. C29 is not. C26 is, though. And then C37 is. So I gotta skip C39. Don't let me forget that. C39. No, 29. C29 is a 1U. Okay. So I gotta do the top and the bottom. So that one and that one. Doot, 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 doot. What the heck? We didn't have enough solder on that. heck? What's going on here with that one? I know maybe you guys can't really see super well, but I think that's better. Okay. Okay, let's clean those up. Probably should use a smaller iron, but tip, I mean. Okay, cool. All right, now what? I do have to come back and get C29, but now I got to do C28 and C31. Are those both? C28, C31 is not. So C28 is. No, not SMD practice at this point. The challenging thing I was trying to do is solder this RP2040, and I think I've done it. However, the problem is I can't really verify it, so I'm trying to just solder all the other components that I'm going to need. There's a little USB programming port here, so if I can get all the components populated, I can attempt to flash firmware to the RP2040, and that will kind of tell me whether or not it's working up to that point. I mean, obviously, eventually I have to populate everything, but for now, I'm just going through the motions. So C28. So that's the next one here. Okay. Yeah, sorry, this part might be a little bit boring. If you want to know more about what I was trying to do tonight, I would go back to the beginning, and because there's some interesting stuff that I tried to talk about that I heard in a different video. So. Come on, anything. Man, sometimes these little components do not cooperate, like right now. Ugh. Where did that thing go? Well, I think I might have lost that one in the void of my desk. Although I suppose this is good practice. Not like I don't need practice, it's just, yeah. There we go. Okay, so C31 is not. Okay, and now we go around the corner. Okay, so what? C34, C33, C36. Let's see what those ones are. C34 is, C36 is, C33 is, C34 is, C36 is. So all three of these are? Yeah. All three of those up here are. Boop, boop, boop. Has anybody seen any good movies lately? I like sci-fi. Yeah, or TV shows. I watched Hunger Games, the Ballad of whatever, Songbirds and Snakes, that one. You know, not to spoil anything from that movie, but I think they really lost me with the later movies. The part 3 and 4 or whatever, I don't know. Not really. I mean, it is a little bit of a spoiler. Well, I won't really talk about that much, but I just don't know, man. Maybe there's just a lot of material, and I just feel like they didn't do a great job of making me care. So, and that's pretty much the same thing with that prequel movie. At the end of the movie, I did not care. Oh, come on. Ooh, you're gonna mod 3 Guitar Hero controllers with USB-C. Where am I? I live in Connecticut, in the United States. Huh, that one looks sus. Okay, that looks a little better. Not perfect, but... Okay. You rewatched Hot Fuzz. It's been a while since I watched that movie, but... You're going to do the, USB-C output for Guitar Hero 3 controllers. That's cool. I have, I just found some of my controllers Guitar Hero controllers. Don't really know if they still work, but okay. So moving along, still C45. So what do we have left? We have C45, R4, C27, C30, R14. Oh yeah, the C24 and C25 are big. Okay. All right, so C45, is that one of these bypass cap or filter caps? C45, yep. C45, okay. I also watched the Halo show, which was all right. I don't know. I don't know if I really consider myself a hardcore Halo person anymore. I used at one point I did. Yeah, I played all the original ones up to 4, I guess. Or no, ODST was probably the last one I played. I read one of the books a long time ago too in school. Currently working on a custom arcade stick for an NES using obviously the OG controller. Oh, that's cool. That's interesting. Are you following a guide or are you just kind of winging it? Okay, so now we need to look up C27 and C30. I think those might both be cap bypass or these filter caps. C27 is, 30 is. Okay, both of those are. We're getting to the end-ish. C30, C27. Okay. Got into Clone Hero and they added Fortnite Festival to Fortnite that looks like Rock Band on Fortnite. Oh, that's cool. That's interesting. Do they work with original controllers like or like you can button map or something so you can use any controller you want? See, you know what? I used to not really like Fortnite. Not like I actually play Fortnite itself, but I kind of think they have an interesting idea with this, adding other types of games like the Lego Fortnite and whatever. It's interesting. It's like Roblox, I guess, which, love it or hate it. Okay, so now I think that's all the caps. Well, maybe I should look up C2 while I have this stuff out. C2. one of these bad guys? It is. Okay, well, while I'm here, might as well do C2. Don't know if I need it for this test, but I will solder it. I know. Alteracious. Yeah, it's a struggle, but that's right. I guess I could just switch it out. That's what I bought this other soldering iron so that I could easily swap tips, but I just too lazy. Okay, so that was C2. All right, what's left around here? R14, R4, is that R4? R14, R4, C29, C31, and then R17 down here. Okay, so I need to put these, I'm going to put these, I'm not really going to put this away because there are definitely a lot more of these specific caps, so I'm just going to leave them out. Well, there goes my my method of trying to keep them all organized, but yeah. But I need to finish all the parts around this thing. We also have to do Y1. So I need to look for C24 and C25. Those are kind of bigger components. So Resident Evil show was a dud. You've seen people map the guitar controller to the PC side, but not so much to consoles. All right, so what did I say I was looking for? C24 and C25. Okay, so these are bigger, so they should be kind of noticeably different. Maybe a little bit noticeably different. See, oh, hey, found it. Nice. Yes, these ones are a little bit bigger. I mean, they may not. Oh man, I still got 100 of them. Okay, so let's get to these. All right, C24. Then I have to do R or Y1 and this R14 too. Geez, these caps are huge in comparison to the ones I was just doing. Ha, that's funny. Feels weird going to the bigger ones. Okay, cool. Well, that was easy. So those ones are finished. There's only 2 of them. You watched the Van Helsing show. Was I right for a season or 2? Then I got worse, so no. PDP is re-releasing one of their old Rock Band guitars. PDP, is that one of the manufacturers of those controllers or something? Okay, so I have to look for Y1, R14, R4. Is that what that says? Ugh, so much gunk here. Okay, so R4, R14, Y1. So let's look for that stuff. Got about 15 minutes left until I'm going to call it a night, but I'm going to be off stream. I'm going to be continuing this, and I'll be if I make any progress, I'll be posting it on Twitter. So, what did I say? R17? No, R14. F1. Okay, not F1. J6. Nope. R2, R3. No, I need R4. J7. Nope. U10. Nope. That's not it. U7, FB, U8, U11, U6, C29, C31. Is that anything nearby? Oh, I see C31. Okay, so C31 and C29. Where's C29? Oh, yeah, that's those 2 here. Okay, so I can do those. Cool. That'll be all these little most of the surface mount capacitors nearby. So this one and that one. What? What? You guys see that? I soldered that. Solder. Yeah, they do. They did have a bunch of room. They probably could have put. I mean, I don't know if I really would recommend. Yeah, I don't know. I mean, maybe if anyone is a technical engineer, maybe they'll know there might be actual reasons why bigger is worse. But like I said earlier too, I don't know if you heard about that or not. This 2.0 version was never really designed for DIY. It was always meant for to be produced. Like these are the ones that Ian sells on Etsy. Is this version? So I don't know. I would have liked to see all of them a little bit bigger, sure. Would have just made it easier if somebody was comfortable with soldering surface mount, but not like micro soldering. I mean, either way, you're gonna have to solder an RP2040, which, you know, I don't even know if I did mine good yet or not. So. It is what it is. But yes, I agree. It should have been. An attempt should have been made for most of the components to be hand solderable. Cool. All right, so that's everything really except for R14 and R4, which actually, let me see if on the BOM they're the same part. I see, yes, R14 and R4 are 1K. Okay, so let's look, and there's a few of them for different reference, different places. So why does this not have a number reference on it? Really? R1, R5, C10, C18, C19. Here they are. Okay. Okay, so I have R14, R4. Okay. Uh-oh. Wait a minute. Shoot. What was this one? C29 and C30, I think. Whoops, I did not put... Okay, that was the right one. Okay. I gotta remember to put the pieces away, or else I'm never gonna... I'm making PicoGUS version 2 somewhere, which is the Gravis ultrasound emulator graphics sound card for retro computers. But this is the version 2, yeah, which is a little bit more difficult, or I guess a lot more difficult. Not a lot, but you have to solder the RP2040 onto the board. Okay, so R14 and R4. I prefer Guitar Hero's guitar over Rock Band guitars because they are better for modding, like mechanical keyboard keys. Ah, interesting. I didn't know that. Interesting. Yeah, I never really thought about it after I stopped playing it and when I was younger. I had not thought about Guitar Hero at all. I know that there's more modern rhythm games. I kind of like Osu, whatever that game is. I mean, it's not really the same, but I knew about that game back when I was playing League of Legends. That was another popular game at the same time. I guess for practicing clicking the mouse or something. It was like an accuracy rhythm game. Oh God, no. Okay. Okay, cool. Well, that can go back in the pile because we're going to need that later. But now I need Y1. Let's see if I can scroll up to what Ian said. Decoupling capacitors, the XTAL, which I learned is a crystal, so that's Y1. The caps on the XTAL. The resistor in line to the XTAL. I think that was everything I just did. Although I don't know if J2 is required. And then the micro USB port and the button. I think actually that's pretty much close to being finished. So here's where the button goes. And then this resistor, I guess I need. And then the USB port over here. I don't know if I need D2. I don't know if I need Q1. Don't know if I need U6. I don't know if I need J2. But I need Y1, and that's the crystal. Gotta find Y1. Where would Y1 be? Oh, here's Y1. Wow, there's a ton of them. Okay. Oh, it's fun looking. Look how fun Y1 looks. So that's another cool thing about doing soldering like this is you get to see all these neat parts. My guess is this is not directional. Although the indicator, the silk screen looks like it might be, but I don't think clock crystals are really ever directional. As in, you can reverse the direction of it and it would still work. Okay, let's see what these pads look like. It's super fun and shiny on the top. What does the bottom look like? Oh, that makes sense. Okay, so it shouldn't be too hard, hopefully, to solder it. You know what? I'm going to switch to a smaller tip for this. Okay, hope I don't make it. I mean, the problem with the smaller tip is it's less thermal mass, so it does take longer. But in this particular case, there's so many things around it that, yeah. Okay, so if I get that started, then I can flip. Ah! That scared me. It takes a really long time. I guess I should turn my iron up. Yeah, let me turn my iron up a bit. Going to 380 from 350. Okay. And I guess I should put some more flux. Okay, so we can always revisit that. I just wanted to hold it in place. See, now it's hard to see if I'm making a good connection under there or not. I might have to switch back to my other tip. That's funny. Okay, so let's try this again with the big tip. Maybe that'll help. See how I can kind of see that I'm making a good connection. Just get out of here. Side solder. Probably should have soldered this first. Jeez. Yeah, this is not going well. I guess. Can't really tell. I guess that worked. But this corner here is really difficult to tell. Ugh. See, now I'm just getting solder everywhere. I guess I should remove these ones, huh? Temporarily, and then just... Although I guess I can always use the hot air gun. I think that's fine. It's kind of ugly, but it works. Oh, it is directional? Oh, okay. Let me look. Crystal still works flipped. Oh. This one doesn't? So wait, Ian, is this backwards? This is, it's kind of hard to read, I guess, maybe. Let me see if I can... Are there actual markings other than the writing? Oh, this one doesn't, fortunately. Okay, I misread that. I think this is fine. So this one could be reversed, I guess, is the long story short of that. But I guess Alteracious was saying sometimes the orientation of the crystal matters. So that's good to know. Okay, cool. All right, so I don't know if I need J2. I don't think I need these pin headers yet or at all. I don't know if I need U8. I don't know if I need U11. I don't know if I need Q1 or D2. I think I need R17, but it looks like it's attached to Q1. But I need the button, the switch here, and I need the USB port. I hate to keep bothering you, Ian, but do you know if maybe you could verify what else I might need? Oh, it is after 11. But that's right. We're hanging out. I need D2. Okay. D2 is here. Here. So I need D2. I need the programming port. I need the switch. Trying to sharpen the... Oops. Oh, the diode that feeds the power from USB. Got it. Okay. That's not many things left then. That's the programming port, switch, and the diode. Okay, well, I'm gonna hop over to the oh, I have a pile of stuff to put away. I think I'm gonna call it a night tonight. I don't know if next time I'm gonna be working on this. Probably not. I think people at this point are sick of me soldering boards. But I am gonna personally be working on it, and I'll be making updates, you know, when I get this program to see if it works. Yeah. But I think next I want to work on fixing the PS2 retro gem. Some people might be sick of that too, because I had like 3 or 4 different streams of that where it wasn't 100% successful. And I think at this point, it's at the point where I believe the audio and the video part work of the HDMI part. The part that doesn't work, which is sort of hopeful, is the controller doesn't work. So I can't actually play any games, or at least I was able to get into the OSD, which you need a button combination on the controller. But I tried playing Dynasty Warriors and I couldn't go through the menu. So I'm not 100% sure if the Pi will boot up as USB if you don't have the flash chip U11. So you might put that too. Also R12. Let me just look at the board. So what did you said? I'll copy all this stuff into a flash chip U12 and U12 and R12. So one last look here. So where's U12 or U11? I mean, sorry. Oh, U11 is here, and R12. Okay. Recapping my air conditioner. Nice. That's funny. Okay, so I'm close. I think I just need a handful of components more, and then I should be able to test this to see if it'll boot. But then I still have a lot, not boot, but well, I guess it would boot, right? Like it should pop up on the computer. Like to bring over firmware. Yeah, anyway, so I want to fix the PS2 gem, retro gem, which it's a PS2 fat, but it'll be a good experience because I'll have the scope now. I wish I had the scope then when I was doing the gem in the first place, but I should be able to at least examine the pins, look at the pins with the scope, and I have the sharp pointy. I bought some pointy probes, pointy multimeter probes that are a lot better for diagnosing, you know, 2 pins next to each other, or see if they're making connection through. So we should be able to hopefully diagnose and fix the PS2 gem. So I might do that in the next video. Afterward, I got a bunch of other projects, but I just kind of remembered the Loopy 3DS, new 3DS XL capture mod that I've got, and I'm kind of curious about that. I don't think it'll be super duper difficult to do, but I think it'll be cool. I also have been hearing. I don't know if this is a spoiler or anything. I think it's still under development, but there is hopefully there's going to be why can't I remember the name of the firmware? The new sound card firmware. I don't know why I can't remember it. I got serious brain fog from I had the flu last week, and I'm still tired and like. I can't remember anything. Not like I normally can remember anything. If anybody's watched my videos for a long period of time, you know I stumble on words all the time. So let's see if I can remember it. I'm going to remember before somebody mentions it. I'm going to cheat. I'm cheating. I think it's just to the point where I learn stuff and then forget it before I commit it to memory. Sound Blaster. Why can I don't know. I was trying to think of AdLib and I forgot AdLib also. Anyways, there might be Sound Blaster firmware for the PicoGUS, which would be cool. And I did a stream where I talked about the 1.4 or 1.1, the DIY version of the PicoGUS, and I never really mentioned that. I think one of the best features of the PicoGUS is the ability to flash firmware from the computer that you're using. So let's say you want to play a game with AdLib compatibility or something, you can just flash that firmware, and then you can switch to a different firmware like GUS firmware or something for a different game, all without having to take it out of the computer. And it wasn't until I watched the Adrian Digital Basement video later on, after my video, that I figured out that you could do that. So that's really killer, and that's something that I would like to talk about. Not a game genie. All right. Thanks, everybody. Thanks, Ian, for helping, and thanks for your project. Yeah, I'll try to see you on Sunday night with, I guess, PlayStation 2. Trying to fix my retro gem.